Captain Jean-Luc Picard, Captain Catherine Janeway, Captain Jonathan Archer, and Captain James T. Kirk, the great captains that explore new places, go where no man has gone before, and discovering new life in the universe. We have seen it on TV, constantly, the Sci-Fi Channel, and all these extraterrestrial beings that exist throughout the universe. Humans have dreamed of the fact of life on other planets and what it might be like. We will go as far as to say we have seen aliens, have been abducted by aliens, and have seen their spaceships, and that the government is secretly hiding aliens and their technology from us for their own personal gain. Nowadays, we even have scientists dedicated to extraterrestrials and groups forming to learn and study outside life forms. The real question, though, is do we have a solid proof that life exists throughout our universe and in other universes? How would we communicate with aliens? What are real signs of extraterrestrials, or are they just myths? And what is needed for life to exist on other planets? Did aliens or extraterrestrials originate from the same area or planet, or did they just appear and form like us humans? These questions have plagued scientists and people for hundreds of years, and we will be examining these in the next few minutes.
Extraterrestrials have been present throughout history in various cultures around the world, including those in ancient India, Egypt, China, and South America. These cultures associated cosmology with the supernatural. Therefore, extraterrestrials and gods often became one and the same. They were seen as all-powerful and all-knowing, and influenced some of the world's oldest and greatest architectural wonders, like the Great Pyramids in Egypt. This idea of beings much more knowledgeable and powerful than we humans will become the archetype of extraterrestrial beings all the way up to the present. It has been perpetuated in different forms of entertainment and mass media for as long as they existed. Orson Welles' radio broadcast of the War of the Worlds in 1938 sparked hysteria of impending Armageddon and multiple suicides across its entire broadcast area. And Steven Spielberg's E.T. the Extraterrestrial has become one of the most iconic and most beloved characters in movie history. This, coupled with countless reports of alien abductions, UFO sightings, and crop circles across the globe, have solidified the notion of extraterrestrials as being intelligent and capable of interstellar travel. But in the scientific search for life on other planets, the main focus is on finding evidence of simple microbial organisms rather than intelligent civilizations.
How did life start on Earth? The study of the origins of life, or abiogenesis, can give us clues on how life could form on other planets, and in turn, how to find that life. One theory, called exogenesis, is that life originated elsewhere in the universe and was somehow transferred to Earth, where life flourished into the many different and complex forms we have today. Other theories hypothesize that life was created here on Earth through a series of natural processes. One such theory is called the primordial soup theory, and states that early in Earth's history, when there was less oxygen in the atmosphere, conditions could have been right for organic molecules to form, creating a primordial soup. These molecules could combine and separate, and certain combinations could have created cell-like structures. One of the most interesting consequences of finding life on Mars would be seeing if its biology is like ours, which means that life could have started on one planet or somewhere else and spread, or if it's different, which means that it developed independently on each planet. Either way, it would give us vast insight into life in our solar system and more broadly, the universe. Life has the remarkable ability to survive in extreme conditions, from super hot deep sea hydrothermal vents to Antarctica, from environments with intense radiation to harsh acids. The discovery of life in such places has led scientists to rethink where in space life could survive. However, there are a couple of requirements that are believed to be essential for life. The first and most important is liquid water. Water is important because it is an ideal solvent for molecules to move around and react in, allowing the formation of complex organic molecules, which are the basis of life here on Earth. These organic molecules are made of the next most important requirement, carbon. A carbon atom has the unique ability to bond with 1 to 4 other atoms, including other carbon atoms, forming complex chains or rings. Along with other elements, these bonds can form organic molecules such as amino acids, which all life on Earth is made from.
Where we look in the universe has a direct effect on how we look for life and how we might find evidence. When looking closer to home in our own solar system, we expect to find bacteria as simple life forms and not intelligent life. The goal is to find physical samples of life or indicators of life for study. Ultimately, NASA hopes to be able to bring back samples directly. Finding this evidence has become the focus of many NASA missions to Mars. The first of NASA's missions were the Mariner missions, in which satellites passing by the planet simply took pictures of the planet for analysis back on Earth. Later, as interest in Mars grew, satellites were dispatched to orbit the planet for a more in-depth analysis. These missions included the Mars Observer, the Mars Global Surveyor, the Mars Climate Orbiter, the Mars Odyssey, the Mars Express, and the Mars Reconnaissance Orbiter. The goal of most of these missions was to use the best cameras and technology available at the time to find evidence of water both above and below Mars' surface. NASA has actually been able to land several pieces of equipment on the surface of Mars. The first of these missions were Viking 1 and 2 in the 1970s, and more recently the Pathfinder missions of the 1990s with the goals to take pictures of the Martian surface. For the first time in history, people were able to view images of another planet taken from its own surface. Currently, the rovers Spirit and Opportunity are roaming the Martian surface, adding a rich collection of photographs as well as taking samples of the soil and analyzing the geology. In the future, NASA hopes to be able to send subsurface machines capable of drilling and digging underground, allowing for analysis of subsurface Mars through the study of core samples. In contrast to the search for life on Mars, any signs of life from outside our solar system would have to be from intelligent beings. It is simply impractical to send satellites and surface machines across vast distances and hope they hit their target. But this does not mean life may not be detectable. By sending and receiving radio waves to and from space, we might be able to communicate with those who might be out there. Detecting these waves is the goal of SETI, the search for extraterrestrial intelligence. Using radio telescopes such as the Allen Telescope Array or the Arecibo dish, SETI researchers scan radio frequency bands to find signs of intelligence. NASA also is making contributions to the search for life outside our solar system. In March 2009, NASA launched its Kepler mission, whose job it will be to scan the sky in search of Earth-like planets by searching for periods of low brightness from the stars, indicating a planet passing between it and the satellite's view.
So, is there life out there? Will we ever know? These are the unanswered questions that will be asked daily until perhaps one day that day will come. Until then, we keep trying to understand the universe around us and whether or not we are alone.